So this video, we're going to expand our study of projectile motion, and we're going to start looking at motion where there's an initial vertical velocity. So if you remember, what we've been studying up till now is the motion of a projectile that is completely horizontal. In other words, there is no initial vertical velocity to it. It starts off at zero. And so as we were saying that, what we saw is that the horizontal component of the velocity won't change over time. There's no force acting on it horizontally, so it doesn't accelerate in the horizontal direction, which means the horizontal component or the horizontal part of velocity won't ever change during its time of flight. However, the vertical component does. It started off at zero, and then because of the acceleration due to gravity, it changed 9.8 meters per second every second as it went down. Okay, so the good news is these are kind of the same type of problems, and both those things will be true, except our vertical component of the velocity won't be zero right now, but the horizontal component will still remain the same the entire time, and the vertical component will change due to the acceleration due to gravity. So what we're going to do is we're going to go back to what we learned about free fall in our last unit when we were doing problems. You throw a ball straight up in the air, how high does it go? And you were given the initial velocity, for that. Those types of problems. And so you guys know how to do this already. It's just a matter of kind of putting it together in a little bit different way. Okay, so. All right, so here's the type of problem that you might be given. So you kick a soccer ball and you kick it at 15 meters per second, shown right here, but you kick it at an angle, and because of that angle, this 15 meters per second, it's gonna be moving up at 7.5 meters per second, and it's gonna be moving horizontally back and forth at 13 meters per second. Now these numbers depend on the angle. We're not gonna worry about how to calculate those. You need trigonometry to do it. So by the end of the year, everyone will know how to do it. If you guys are interested, you've had trig before, and you're interested to see how to do this, I'll be happy to show you. But for this class, you'll be given both of these components. We don't have to worry about the angle. So we have an upward part of 7.5 meters per second, and we have a horizontal part of 13 meters per second. Combined makes 15 meters per second. So this is our actual velocity, but we can break it up into these two components. And so the questions that we'll want to know about this, or that you guys are going to be asked about this, is, hey, how high will this go? What's the maximum height that this ball will go? How far will it go? Okay, so from the point you kicked it to the point it returns to the ground, how far will this go? And that's the horizontal distance, is how high is the vertical distance. And then you'll also be asked, this is kind of more of a conceptual thing, what speed will it have at the top? And you'll see that that's actually a really easy question to answer. Okay, so let's look at how to do this. So let's first look at how high the ball will go. And as I was saying, it will go the same height as if you threw it straight up at that initial vertical velocity, v sub v naught. So in this problem, we just look at that vertical component. So if you remember, right here, so the 7.5 meters per second. So we say, okay, well, if I threw it upwards at 7.5 meters per second, how high would it go? And so we go back to our free fall. We have to define up as positive, and so that means our acceleration is going to be negative. And this is a little bit different. Before everything was going down, so we could kind of drop this negative, but now we have to bring it back because we have an upward velocity initially. So that's going to be negative. And if you remember, what we were saying is that, well, okay, when it gets up to the top, I know its velocity is going to be zero, so I can use this kinematic equation. This final vertical velocity right here will be zero at the top, so I just put zero in there. This will be my initial vertical velocity, so I'm going to square that. And then I'll have 2 times negative 9.8, don't forget that negative, times the distance, delta x. And then you do some algebra, which I'm not going to show you guys here. You guys can work that out. But what you're going to get is a height of 2.9 meters. So it's going to go to a maximum height of about 3 meters up. Okay, so again, you've done this problem before. This is just like a free fall type of problem. Okay, so that's how you do it. Even though it's being kicked at an angle, even though it's got a part that's going horizontally, if we know the part that is vertical, we can calculate how high it's going to go, just as we did in the last unit that we studied. So how far will it go? Now this one's a little bit trickier, and as I was saying earlier, that in class, that what we want to do is we want to find, okay, well, how much time will it be in the air for? And if I knew how much time it was going to be in the air for, I can use this equation, my horizontal velocity times my time, to get my horizontal distance. So really, a lot of this down here is just figuring out how long it's in the air for. And we can say that the total time it's going to be in the air for would be the same as the total time as if you threw it straight up in the air. So again, we've done this problem already. You just, instead of using the whole velocity, you just use this vertical component, and you say, okay, I'm going to throw it up, it's going to come back down. I'm going to have my acceleration of negative 9.8 meters per second squared. And I'm going to use this fact that the time to the max height is going to be 1/2 of the total time. So I'm going to use, again, this idea v is equal to v naught plus at to get the time. I know this is going to be 0 at the top. So I plug in my initial vertical velocity, my acceleration, I solve for time. I get 0.765 seconds. 2 times that is the total time in the air. And so I'm going to get 1.53 seconds. So again, we use the vertical velocity and we use the vertical acceleration to figure out the time it's in the air for with this kinematic equation. Then, once we know the total time in the air, we can go back to our non-accelerated horizontal distance equation, and we can say that, okay, my horizontal velocity, which remember is 13, it's just that horizontal part of the velocity is 13 times the total time in the air, 1.53 seconds. I'm going to get 19.9 meters, or about 20 meters altogether. Okay, so that's how we do that. Again, we find the total time in the air, just as we did with horizontal projectile motion, and then we take that total time in the air and we multiply it by our horizontal component of the velocity. The only difference with this is we now have this upward part of the velocity so we're going to have to take that into account in our kinematic equation to solve for total time. Okay. All right, then this last question, what is the speed at the top of this path? This one's actually really, really simple. Okay, it's a conceptual type of answer. So we have this ball being kicked at 15 meters per second, and then you're given the upward part, and you're given the sideways part. And just remember, this upward part changes. Okay, it's going to change. So it's going to decrease as it goes up until it hits 0 at the top, and then it's going to increase the negative direction as it comes back down. This stays the same the entire time. So as this is traveling, my upward component gets less and less and less and less and less until it hits the top, and then all I'm left with is the horizontal component, the side-to-side component. So the speed at the top of the path will be equal to the horizontal part of the velocity. Okay, and that will be true. That will always be true. Okay, so I think that's pretty cool. So at the top of the path, the speed's going to be equal to its horizontal velocity, and so it's just going to be 13 meters per second. There's no calculation you need to do for that. You just have to know this fact. Note that it doesn't stop. Okay, it still has that velocity, but it's just going to be this horizontal part. Okay, so that is how you handle projectile motion when you have some initial vertical velocity. And again, we will practice this in class. And if you guys have any questions on the notes, please let me know.